What's going on, folks? Welcome to Algebra 1 class. Let's get this party started. Is it only you two? Can you hear my voice all right? Say yes or no. Awesome. Then do me a favor. Today, I'm going to help you out the best way possible, but I'm going to make a deal with you. Since it's just you two today, I want you to respond quickly. I want you to all, like, if I ask you a question, like, say hello on the chat. Go for it. Say hello. See how long it takes. Awesome. Good. You guys are on it. Stay on it. Stay on the ball today. And today's class is scheduled for almost a 2-hour class or an hour and a half class. Why don't we just do this? Why don't we go for a straight hour? And I'll help you out with as much as I possibly can. We'll go for a straight hour, and then I'll finish early. Sound good? Okay, awesome. Okay, let me just get this thing here and do this right here. And let's start reading the text and go through it. Alright, here we go. Mr. K. Aloha was having a bad day. He spilled his coffee on him, and he accidentally ate a bug or something like that. So basically, he wants to. His copy machine got all messed up too, and he was trying to make a copy of something. Let's see. Oh, I see that. Okay. And so what he did was he made a copy and he got all messed up. Looks something like this. He knows the equation of that parabola. This is what we call a parabola here. And the equation of it is f of x equals x plus 3 times x minus 4. Close parentheses. That's the equation right there. And I think I went through this with you on Wednesday, and I think I went slowly through this with you. You guys were here on Wednesday, is that correct? Yeah? No? Do you remember if I went... Okay. Do you remember if I went over the parabola with you on Wednesday? Things got all blurred up for me because I actually had an Algebra 2 class that day. No? Okay. All right, so I guess I'll go through this with you. What is the y-intercept of the function? All right, so first of all, let's identify where the y-intercept is. And then all we got to do is zoom in and count it. So the y-intercept is, I'll give you 3 options. I'll give you point 1, 2, or 3. By the way, this is the x-axis and this is the y-axis. Where would you say the y-intercept of this function is? At point 1, 2, or 3? What's your thoughts? At point 2, right? It's the one on the bottom. It's where the line crosses the y-axis. I mean, that's why they call it the y-intercept. It makes sense to me. Does it make sense to you? We good? Say yes. I need you guys to be on it today. Today I feel like a day where I just kind of want to interact with students. So let's figure out what the coordinates of that point is. And I think to best do that, let's take a look at this graph and we'll zoom in here. There we go. Zooming in. There we go. All right. So first of all, we need to figure out, well, how big is each of these boxes represent? It looks like it's what is the units of this thing? Am I counting by tens? Am I counting by ones? Am I counting by 100? Come on, respond, chat bar. There we go, 1. All right, so it's 1. So where would you say the y-intercept is? How far down? Take a look, count it. -6? Is that what you guys, does everyone agree? All right, -6, awesome. So if I were to give you the coordinates of this point right here, what would that be? Give me the coordinates. I'll give you a hint. What I mean is it's got an x, it's got a y value. It's called an ordered pair. 1 comma negative 6. Close, Jillian. Not really. You're one number off. 0 comma negative 6. There we go. Exactly. 0 negative 16. That's totally off, but I think I know you just typoed it on accident. All right. Exactly. It's 0 comma negative 6. Jillian, do you understand why it's 0 comma negative 6? Okay, yeah, exactly, because it's a 0 because we're talking about the x-intercept. And when we, or no, not the x-intercept, excuse me, I messed up. We're talking about the y-intercept. And when we talk about the y-intercept, that's where x equals 0. I mean, that's kind of defines the y-intercept. Wherever you are on the y-axis, you know that that first number is going to be 0. Do you guys agree with me? Because we're talking specifically about the x-intercept. And yes, I agree with you. All you got to do at this point is just say it's equal to negative 6. Huh. I'm actually looking at something and I'm thinking that that might actually be wrong. We are doing the functions for. So I'm actually doing stuff that's you haven't done yet. This is stuff that's coming up next week. All right. Okay. So here's the thing. What is the value? All right, so to be honest with you, I'm questioning whether this answer is correct or not. And I think I have my reasons why. I'll explain to you what I think is going on, but I'm kind of foreseeing what might be, there might be a problem here. Okay? And I'll tell you what my thoughts are on this. You guys said that the scale of this going this way is, it looks like it's 1 unit, 2 unit, 3, 4, 5, and this is 6. You guys agree? You guys see what I'm saying here? And that was based on the assumption that this line right here was 1. Because that's what the graph said. The length from here to here is 1. So it looks like this is the same length vertically, so I would assume that that's 1. Here's where I would say we might be careful. Actually, you know what? We'll keep on reading. Hold on. Oh, here we go. It says, what is the y-intercept of the function? Be careful. Although the x-axis is clearly marked with the scale of 1, the y-axis doesn't necessarily have a scale of 1. Look, we could have read the problem and realized that there might be a problem. And I'll tell you why I thought that there might be a problem. I don't think that this is negative 6. I honestly think it's negative 12. Would you like to know how I was able to get that? Awesome, Raven, I love you asking me questions. All right, here's what my thoughts are, okay? I'm going to go back and say we don't necessarily know what the y-intercept is, correct? But if I were to give you the points of the y-intercept, the first number I would give you is a 0. I would say 0, comma, and I would say some number, probably negative 6 or negative 12 or something like that. Right? Because I'm talking about specifically the y-intercept, and whenever I'm talking about the y-intercept, you let x equal to 0. Just like if you're talking about the x-intercept, you let y equal to 0. You guys agree with me there? So all I have to do then is to figure out the y-intercept. If they gave me the equation of the function, which is the best way, I think, best thing to give me, because you can always pull out all this information off of it, is you have to evaluate what that function is going to be when x equals 0. So all we want to do is figure out what f of 0 is. You see what I mean? Yeah, you plug in 0. So if I plug in 0 into here, this is x plus 3. All I got to do is put a 3, because 0 plus 3 is 3. And then over here, this is a negative 4. 3 times negative 4 is negative 12. So, this point right here is actually negative 12. Which would mean that this thing doesn't count by ones. It doesn't go 1, 2, 3, 4, 5, 6. What does it go by? Twos, exactly. It goes 2, 4, 6, 8, 10, negative 12. So it's actually negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. And that, my friends, is mathematically how you figure out what the y-intercept is. Anytime you want to figure out what the y-intercept is, you plug in x equals 0. Anytime you want to figure out what the x-intercept is, you plug in y equals 0. That makes sense. All right, here's my next question. Ready? By the way, the ordered pair for this point right here would be negative 0, negative 12. Are we cool? Do you like it? Raven, you're saying you would count by odds? I suppose, but that would be a little weird to do. Actually, no, it wouldn't come out the same because you would go, what? 1, 3, 5, 7, 9. Well, the next one's 11, Raven, not 12. That'd be a weird jump. All right, I'm going to erase this part right here. So take a picture if you want. I'll give you a second. All right, good. So my next question is this. What does F5 represent? What F5 represents is what is the value of this graph when I'm standing at x equal to 5. Well, that's pretty easy. That's pretty straightforward. Would you like to know how to do it? All right. What's the equation? It's kind of hard to see. Well, you can kind of look at it right here, and that's actually easy to see. X plus 3 times x minus 4. That's what I'm supposed to write here. Cool? All right. So all I got to do is plug it into the equation. I just plug a 5 into there. That would be 8 times 1. Huh. Okay. So what you're telling me is, all right, let me make this graph a little bit clearer. That would mean that a point on this line exists at 5, because that's the x, and the y value, the corresponding y value would be 8, so 5, 8. Is that true? Let me look at this graph a little bit better. I'm going to zoom in right here. Okay, if I'm standing out at 5, okay, this is x equals 1, x equals 2, 3, 4, 5. Okay? So it'd be some point way out here. That goes all the way up to about here. Would you say that that's y equal to 8? Actually, when I look at it, 2, 4, 6, 8. It could be y equals 8. Because remember, we're counting by 2. So it's 2, 4, 6, 8. Yeah, sure. All right, I'll agree with that. At this point, 5, 8 exists on the graph. It's right there. Does that make sense to you? I know. I would have said it doesn't go up high enough, but then again, when I look at it, I realized, wait a second, when we're talking about the y-axis, we're counting by 2s, 2, 4, 6, 8. So it does go up high enough. By the way, I'm sorry, I gotta go do something real quick. I have to turn a computer screen thing. Take this. Give me a second. Sorry. Arg. There we go. Okay. I'll give you a second to process that information. Actually, I gave you your second already. Let's see. What did you say? Because the max is 12 on the graph, so it was a little confusing. I'm not sure what you mean by the max is 12. All right, let's read the next part. Based on the graph, the function has a 0 at x equals 4. What we mean by a 0 is we're saying the zeros of a parabola is where the graph crosses the x-axis. A zeros is really another name for x-intercept. So let's verify that. Let's make sure that that's true. I'm going to erase this part right here. All right. So at x equals 4, they say that this graph goes to 0. And I would say by the graph, this is 1, 2, 3, 4. That could be true. That looks like it goes to x at y equals 0, right at x equals 4. So let's calculate what x equals 4 is. 4 plus 3 is 7. 4 minus 4 is 0. 0 times 7 is 0. So therefore, x equals 4 is a good answer. It is one of the x-intercepts is at 4, 0. Does that make sense? We cool? All right. So far, I've got Raven only talking to me. I told you I want everyone to talk to me. So chime in. You know, don't be afraid. Raven's so brave. Jump in there. Awesome. Good. Cool. Now, I have a question for you. If x equals 4, do you think, here's my question, do you think just by looking at this graph, or this equation, would you be able to tell me that x equals 4 is a 0? Do you understand the question? Is there any hint in this equation that tells me that x equals 4 could be one of my answers that I'm looking for? Okay. I'm assuming that you guys are referring to this part right here. Am I correct? Okay. All right. Kind of what? Kind of both. What do you mean by kind of both? I'm assuming that what you're saying is, you know that x equals 4, I was able to figure that out because of this part right here. Because this part right here was equal to 0, right? Right, you got the 4 plus 3, which is equal to 7, and that doesn't matter. But the 4, or the 4 minus 4, that gave me a 0 there. I like that. That's a really good thing. Because that killed the whole thing and made everything on the right-hand side equal to 0, which is what I wanted. You guys see what I'm getting at here? So therefore, x equals 4 was a very good possibility for me to try. Do you understand? Do you understand kind of what I'm getting at here? So if that's the case, then tell me x equals what other number is another x-intercept that I would like to try. What other number would you like to try to plug into this equation to make it equal to 0? I'll give you a hint. All right. Raven says -4. Rainey says -4. Let's try it. Let's try -4. Okay? So I've got f of -4 equals -4 plus 3 is -1. Okay? -4 minus 4 is -8. -1 times -8 is +8. That's not 0. I wanted 0. So -4 is not the correct number that I was trying to refer to. All right? Try 0. Okay, we can try 0. But actually, Raven, we've already tried 0. We've already plugged in 0 into here and we got negative 12. And that's how we got the y-intercept in the first place. I don't think you guys are understanding my hints here, okay? Now, since there's a lot more people in on this, I want everyone to chime in because I'm only getting Raven and Rainey so far. And a little bit of Bailey. But here's what I'm saying is, from this equation, we were able to figure out that x equals 4 is one of our intercepts. And it's because we looked at this second part of the equation and we said, hey, I want this second part of this equation to equal to 0. Because when I plugged in x equals positive 4 into here, I got positive 4 minus 4, and that right-hand side is 0. This part is 0. And if that's 0, it doesn't matter what this first part is, because the right-hand, this part is 0, and you multiply any number times 0, the whole thing is going to be 0, which is a good thing. So here's my question is, what is the other x value that I will want to try in order to make this f of x equal to 0? All right, we tried 4, Jillian, we tried. We put 4 in there, and that made 4 plus 3 times 4 minus 4, and that made this thing 0. So it doesn't matter what 4 plus 3 is, which is 7, but it doesn't matter because 7 times 0 is still 0. So 4 does work. I want to figure out another number that will get me the whole right-hand side equal to 0. And, all right, I'm going to have to give you another hint because I think that I might be confusing you guys. We looked at this second term right here, right? What about this one right here? Look at that number. We're going to want to do something with this part right here. All right, here's another hint too. You can look at the graph. What we're finding here, what we're trying to find here is what values of x gives me 0 for my y values. So we figured out that x equals 4 is one of my answers. There is another point on this graph, right there, where y is equal to 0 as well. What is the value of that point? Is it negative 4? It's all right, so you're saying negative 3? Jillian is saying negative 3. Why don't we try that out? If I plug in f of negative 3, I'm going to figure out what f of negative 3 is. I'm going to plug in negative 3 into here, so that's negative 3 plus 3 times negative 3 minus 4. Got it? This negative 3 plus 3, that's 0. Negative 3, wait, it doesn't even matter what the rest of that is, because if you have 0 times any number, it doesn't even matter what that number is. It's 0. Right? So yes, Jillian, absolutely. Our other coordinate is negative 3, comma 0. This is the coordinate of our x-intercept. Negative 3, comma 0. The other one is 4, comma 0. Now, Jillian, I have a question for you. How did you get negative 3? Did you look at the graph? How did you get negative 3? Was it just a guess? Because there's already an a plus. I see. You looked at the graph and Counted the x. Okay, well, see, the thing is, when you look at this graph, it didn't print out, so you can't really 100% be sure. But I like where Raven's mind is going on this one. I think what Raven is saying is, oh, I see. Rainey is saying, wait, the vertex of this parabola, the vertex being the lowest point of this parabola, isn't exactly on the y-intercept. So it's kind of shifted to the right. Is that what you're saying, Rainey? The whole graph is shifted to the right, so it's not going to be +4, -4. It's going to be like a little bit off. But I like where Raven's mind is going on this. Raven is saying that, but wait guys, you can take a look at this equation right here and get -3 from that. Just like when we can take this equation from here and get +4 from that. We can see where that +4 comes from. Because you look over here, if you plug in 4 over here, that makes this second term 0, and that is a good thing. Over here, if we plug in -3 over here, that first term, because the -3 plus 3 is 0, it doesn't matter what that right-hand side is, because I'm multiplying this thing times that thing. If the first thing is 0, everything is 0. So that's Raven's... Am I correct, Raven? Is that your thought process? Is that what you're thinking? I just want to show you because I think it's cool. I think it's cool that you can take an equation and then immediately tell me what the x-intercepts are. Good. Well, I'm glad that you understand this. All right? I have a question, because I want to be a good teacher. What is, do you guys feel like I'm explaining this well? Okay. The last part, because this is still warm-up. I'm not even sure if this is a part of your homework, and I want to get to your homework because I want to help you out. I want to be nice. I'm going to erase this last bottom part, okay? Okay. Rainey mentioned that the vertex of this parabola, look at this graph, because the graph is much prettier than mine. But the vertex of this parabola is not exactly on the y-axis. Where would you say it is, Rainey? At x equals what? Take a guess for me. And not just Rainey, but what x value gives me the vertex? What is it? At about half? Does everyone agree with Rainey on that one? Yes or no? I want you to chime in. Everyone can agree or disagree. Come on. There's more people than in the class than Rainey. All you got to type is y or n. Raven says y. Yeah, all right. Come on, I'm waiting for Jillian and Bailey and Andre. Awesome, awesome. Bailey, I'm not sure what your answer is, but okay, all right, cool. So I've got the majority saying it's about half. It's not exactly at x equals 0. It's not exactly at x equals 1. It's about 0.5. If I were to draw a dotted line, that would be the lowest point right here. It would be about halfway between 0 and 1. I totally actually agree with you. If that's the case, what would you say the y value is? I'm just curious. The vertex is at this point right here, which is 0.5 comma what? And just take a guess by looking at the graph. -12? I disagree with you on that one. You're close though. Keep going a little bit more, Raven. -12, not -12, go a little bit more. Go a little bit more negative. -14? Okay. Yeah, I actually think it's less than 14 easily. Because remember, we're counting by 2, so this is -2, 4, 6, 8, 10, 12 down here. The vertex is right over here. 14 is way down here. I'm pretty sure it doesn't go to 14. I would say 12 and a half. Yeah, I think that's a fair guess. Yeah, all right. It's between 12 and a half and 13. Negative 12 and a half, negative 13. Right? So what we'll do is we'll plug in 1/2 into here. So I've got f of 0.5 equals 0.5 plus 3 times 0.5 minus 4. This is 3.5 times 0.5 minus 4 is negative 3.5. Someone got a calculator? What is 3.5 times 3.5? You're right. What is 3.5 times negative 3.5? Do you have a calculator on you? I don't got mine. Negative 12.5. Awesome. Or no, 12.25. That was so poorly written. I'm sorry. Negative 12.25. Great job. So this is the value of our vertex. It's the lowest point that in which the graph goes to. This is the y-intercept. These are the x-intercepts. Let me recap what we did and how we did it. All we did was we were able to take a look at this function and give you a whole bunch of points. The first point we got was the y-intercept. And the way we did that is we plugged in x equals 0 into the equation. Right? The second thing we did was we looked for what we called the x-intercepts. And that is where you get a value of y equal to 0. We call those the zeros of the function. So if I told you find the zeros of this function, all you do is you basically figure out what the x-intercepts are. There were two of them. 1, 2. You can see how this graph crosses the x-axis twice. And what we did, yeah, exactly, there were negative 3 and positive 4. Those were my two x-intercepts. And the way we were able to guess those is we looked at this right here. And we said, hey, if I plug in positive 4 over here, that will make this term 0, and then I'm home free. If I plug in negative 3 over here, that will make that term 0, and I'm home free and I'm good. Cool? And then the last thing we did was we guessed the whatchamacallit, the vertex. All right, let's move on. Can we move on? I'm going to erase this. Take a screenshot if you want. All right, screenshot done? Okay, I'm erasing. All right, now, most of you guys are saying, yeah, but when will I ever use parabolas in my life? Well, let's read this next one. Malama wants to fence in a rectangular area of her garden. Her mom, Miss Aina. Aina. Malama Aina. Wait, seriously? The lady's name is Malama Aina? Wow. That's so Hawaiian. All right, anyway. Aina provided... Hawaiian rock. All right. Malama Aina her mom provided her with 100 feet of fencing for this purpose. There are many, infinitely many actually, dimensions for a rectangular garden, assuming she uses 100 square feet. Here's a diagram of the possibilities. Well, she could go 1 foot by 49 feet, because she has 100 square feet, right? So it's 1 plus 49 is 50, plus 1 is 51, plus another 49 is 100. She could do that. Got it? Another thing she could do is she could do 10 by 40. Now this would be good if she had a really long wall to put it on. You know what I mean? Like if all she wanted to do was build a garden that goes out 1 foot, but 49 feet, like the entire wall. So if she wanted to, like, I don't know, plant carrots or something, and she was like a rabbit and she planted carrots in a row, all right, fine. I think it'd be ridiculous because you would have to walk the entire wall just to pick up all your stuff. Or when you water, you would have to water the entire thing. I think that would just be kind of a dumb thing to do. But anyway, apparently that's what you would do. And then if we calculated the area of this thing, the area is what? 1 times 49, that's 49 feet squared. So this is 49 feet. This is 1 foot. 49 feet times 1 foot is 49 feet squared. Did I just confuse you? Do you guys understand what I'm saying? All right. Another thing she could do is she could do a 10 by 40, and in that case, her square footage would be 400 feet squared. Oh, awesome. She gets way more square footage doing that configuration. She'll use the same amount of fence. She'll just use 10 by 40, that's 50, plus another 10, that's 60, plus 40, that's 100, right? But she gets way more square footage. Cool? And then the other one, she can build an even fatter rectangle, and she can go 20 by 30. And then this would give me 600 square feet. Does this make sense to you? All right. So what I want to do is I want to make a table. And over here I'll have the length of this. And I guess I can put another column called the width. And I'll have the area column. Got it? All right. So the length, if the length is all right. So if the length is 1 foot, so that would be this length. The width would be 49 feet, and the area would be 49 feet squared. Right? I put that in my table. But why did they give us the length? They gave you just the length and the area. I gave you the width just because I think that information might be helpful to us. It's kind of like this intermediate step. So I think that adding the width column would make it easier for you, not harder. It's easier for me to understand. Do you see where I got 1 and I got 49 here? Okay. All right, so I got that one. All right, let's get another entry of this column, or of this table. Let's see. If I have a 10-foot length and a 40-foot thing, that would be 10 feet here, 40 here, and this would be 10 times 40, which would give me 400. That's another point on my graph. You guys see that? All right. I would argue with you that I actually got 2 points from that. I would say this one would be 40. This is going to be 400. Did you figure out how I got that one out? How I got that one down there? Because this is saying I have a length of my garden is 40 feet. What would the width of my garden be in that case? If this is 40 feet, the width of my garden should be what? 10, exactly. And then 10 times 40 is 400. It's kind of like this garden and this garden is exactly the same. All I did was I rotated it 90 degrees. Right? You see what I'm getting at here? All right. I'm going to do this. I figured out a 20 by 30 will give me 600. But I don't have 20 over here. I could add it, I guess, if I wanted to. I didn't put 20 as the length over here. But I do have a 30 over here. Yeah, exactly, I have a 30. So what should I put here? 20, exactly. And 600. Cool? Alright, let's figure out another one. And I'm going to let you graph this, and I want you guys to take a look at what this thing makes. Say that we have a 25-foot one. Okay? 25 feet for the length. What would the width be? Remember, you have to have the perimeter equal to... Raven says 4. I disagree with you, Raven. What would the width be? Yes, I agree with you. Andre says 25. Exactly, Andre. I see what you're getting at, Raven. I think you're thinking about it too hard. The top would be 25 because, like Raven says, 25 plus 25 plus 25 plus 25. That does give you 100 true. So 25 by 25. So this would be 25, 25. Those of you with calculators, I don't have one on me, but what is 25 times 25? Yeah, you totally were on the right track. You just said 4. 4 is not the right answer. It's 25. But what is 25 times 25? 650. Cool? All right, this table is fun. Let's try this. What is 24? If this were 24, what would this be? Okay, if this were 24 down here, this shouldn't be 24. You want to use up all of the 100-foot fencing. Yeah. What would this top or bottom be in that case? Yeah. What Raven is saying, 24 times 4 is 96, so you don't want it to be 24 by 24 by 24 by 24. Because you're going to have 4 foot of fencing to use. Oh, I'm sorry. 25 times 25 is 625. You're right. Raven's saying something. Yeah, if this were 24 feet, how long would I have to make this in order to use up a 100-foot fence? Look at the pattern here. I've got 149, I've got 1040, I've got 3020, I've got 4010. I got 2525. Look at those numbers. I'm not going to give you the answer all the time. 27. No. All right, fine. I'll put 27 up here. 24 plus 27 is 51. Plus another 24 would be 75. Plus another 27, that's 102. That's too big. Rainy's saying answer. 76. Oh, you're right, 76. Ah, there we go, Jillian. You just put 26. Yes. If this side were 24, this should be 26, because 24 plus 26 is 50. Plus another 24 is 74. Plus another 26 is 100. Awesome. Great job. It's 24, 26. I'll tell you the pattern. The pattern really is, whatever this number is what it takes to get to 50, the number 50. All right, 624. 624. Okay. So let's graph this. All right, let's graph this. Uh, 10, 20, 30, 40. You guys see? This is a 10 down here. And then this would be 1, 2, 3, 4, 5, 6, 100, 200, 300, 400, 500, 600. We cool? Oh, yeah, I'll tell you what, I'll let you guys do 5 and 27. You guys figure it out. I mean, I'm not going to do all of your homework for you. Come on. Right. You do that. You do that. Okay? At x equals 1, or at L equals 1, so this is the graph of L, and this is the graph of A. At L equals 10, A equals 400. There's 1 point right there. At L equals 40, it also equals 400. At L equals 30, this graph equals 600. Would you like to take a guess at, if L equals 20, what is this graph going to be? At L equals 20, what is this A going to be? Ugh. 600, perfect. How did you get that? That's amazing. Yes, exactly. All right. At L equals 25, this thing was 625. So it's up there. At L equals 1, way over here, A equals 49, so about halfway over there. You guys see that? What is this a graph of? If I were to connect the points, is this the graph of a straight line? Could I use a straight line to connect? It's a parabola. Exactly. And this tells you what the area is all the time, or what the area is as a function of L. Right? So here's what the advantage of a parabola is. This thing is what makes parabolas really cool. Is if you ever want to find the highest point at something, you would need to understand the idea of a parabola. If you ever want to find the highest thing you'll get, then you'll want to understand the parabola. Like say that Malama Aina wants to build the largest amount of square footage for her garden as she possibly can. Well, she wouldn't build a 1 by 49 foot garden. She would build a 25 by 25 foot garden. Does that make sense to you? And you can see that because the area is biggest here. Yes, that makes sense, Mr. Dolde. No, that doesn't make any sense. Sorry, I can't answer that phone. Yeah, because it's half and half, there's a balance. But here's the thing. What if I change the idea of this problem? Sorry, the phone's ringing and I have to, I'm actually in class right now, so stop calling. All right. What is the idea of this thing? Well, the idea is, what if instead of this being the area, this was the amount of money I made? This is $100, $200, $300, $400, $500, $600. Okay? And this was some other variable here. This was the amount of work I did. Okay? So this is the amount of work I did, this is the amount of money I made. Yeah, something like that. Hours of work, how's that? Hours per week or something. Maybe for some reason if I overworked it, if I did too much work on it, it actually got worse. So, okay, fine. I would want to know what this curve looked like. That way I could figure out the exact amount of time or something I should sell, something I should work, so that I would maximize my money that I make. Right? Why would you want to work more hours if you make less money? So you want to work the perfect amount of hours or something like that, so it would make you the most amount of money. So this kind of idea, the idea of fitting a curve like this and understanding how to get the vertex is really important when it comes to business. And I know that a lot of you guys are saying, well, Mr. Balde, I'm never going to be a mathematician, or I'm not going to grow up to be a mathematician. I have no aspirations to be like a full-on scientist or engineer or whatever. So why am I learning this math? Yes, I know. But whether or not you're a makeup artist, or you're a janitor, or you're a mathematician, you are going to need money. So you would want the middle point. So exactly, Raven, we would want to figure out a way for us to get to that point right there, instead of getting to that point or that point. We want the sweet spot. That's the sweet spot. Cool? All right, I'm going to erase this. Can you take a picture of this thing? Now it's sad because I only got through 2 pages and it's been an hour. I know that I told you I would finish. Oh wow, they graphed it for us. Look, that's what the graph looks like. Hey, that's very close to what we graphed. All right. So I can erase this because they already have the graph for you. Are you guys tired? I'll tell you what, I'll give you the option. And this option is actually, you know what, I'm going to give Bailey and I'm going to give Rainey specifically the option. Bailey and Rainey, it's up to you, 100%. Don't feel bad if you say, for whatever you say. Since you were the two who came into class on time and were ready to go, I'm going to ask you, would you like to end class now or would you like to go for another 15 minutes? Because I told you that at the beginning of class I was only going to go for till 10 o'clock, and then I was going to say if we can finish early, we can finish early. But we have got other people in here, so I wouldn't mind going on because I only went through page 4. I didn't even go through page 4, I went through page 2. So I didn't get a whole lot finished, but you know what? It's up to you. I got an and an IDK. I'll tell you what, Bailey and Rainey. If you would like, you can jump out. I'm going to keep on going, and I'll only go for I'll finish this page. Does that sound fair? I'll talk about this page. Work my way through it. Alright, cool. Nalu was training for an upcoming wrestling season. His coach told him to sit-ups is a good conditioning exercise. Okay, after 1 day of conditioning, Nalu was able to perform 40 sit-ups without stopping. Alright, cool. So, after 1 day, his sit-ups is 40. By the end of the 2nd day, his conditioning improved to 45. By the end of each consecutive day, Nalu was able to improve by 5 sit-ups. Oh, cool. So 3, 4, 5, 6. So the dude did 50 here and 55 and 60 and 65 and so on and so forth. All right, here we go. How many sit-ups could Nalu do before he started his conditioning? Well, he didn't do any conditioning. He'd probably do about 35. Yeah, I totally agree with that. I don't know why I put 34. 35. Awesome. Nalu was able to... All right, so we completed the table. Done. Hopefully you found that... Or you did not add 5 over and over again in order to find day 37. Oh, I see. So they went all the way up and then... I get it. They did 1, 2, 3, 4. They didn't do all this. I got a question, is 37. So there's a dot, dot, dot there. Because it goes all the way to 37. How are we going to get here? What is 37? And actually, Raven, no, what we're saying is, it's not saying that 0 equals 35. It's saying that n0, oh, you can't see that, sorry. It's saying that n of 0 equals 35. So that's saying the number of sit-ups he could do at 0 days is 35. All right? Okay. Raven is saying that in order to figure out what to plug in here, we just do 37 times 5. What is that? What's 37 times 5? Use your calculators. I don't got one on me. 185. So the dude could do 185. I think that you're cheating him out a little bit. I think he can do even more than that. To be honest with you, I think he could do 220 sit-ups. I don't think it's 185. I think it's more. I think it's 220. Well, here's what my argument would be with you. You told me that in order to get this number, you simply multiply this number times 5. Agreed? That's what you just told me. You said in order to get this, I take 37 and I multiply them by 5. If that's true, then that should work over here. Okay, fine. What is 5 times 3? 15. Then how did we get 50? What is 5 times 5? There we go, Raven. You said you add 35. Why would we have to add 35 to this number to get 50? And everyone can answer, please. Everyone answer. Why did I have to add 35 to make this graph work? Because he started off with 35, because he could do 35 to begin with, so you need to take that into account. So everything is offset by 5. So at 37, don't just multiply 37 times 5. You have to add to that the original 35 that he could do without any training to begin with. Which makes me wonder how many sit-ups I can do. Especially after a month. Can I do 220 sit-ups? I don't know. I'm fat. But anyway, absolutely. So the equation is the number of sit-ups he can do per day. So this is saying the number as a function of days is equal to 5 times the days, right? Plus what? Plus 35, plus the original spot that he started off at. 5d plus 35. We just figured out the equation. Now you're going to need to graph that equation. You've made the table, graph it. You'll probably get something where, see this 35 right here, what do we call that? If you compare this to the y equals mx plus b, what is the 35? The 35 is the b. It's the thing that is called the y-intercept. So over here is 35, and then it just goes up with a slope of 5 over here. It's an equation of a line. We cool with that? All right, folks. That's all, folks, for now. I'll see you later. I'm going to get ready for teaching physics kids. All right. Talk to you later. Okay, bye.